Hi friends, I'm back with the new addition to my Beginners Bioinformatics series. Let's learn some more fundamentals. Earlier, we learned how to use Blossom 62 matrix and how BLAST works. If you have not watched these videos yet, please check the links in the description box. Today we are going to learn using examples how, while aligning two protein sequences, BLAST-P estimates and assigns a gap position. I hope you are enjoying and learning something new from my videos. Please do not forget to like, subscribe and comment. As we know, BLAST is a software or tool which helps us to assign and compare two sequences, meaning it performs a pairwise alignment. Protein BLAST or BLAST-P is a basic type of BLAST which is meant to align protein query sequence with a protein database sequence. In a protein-to-protein alignment, we may observe some gaps, and a gap represents an indel event, means during evolutionary process, a sequence might have acquired one or more extra residues, which is insertion, or the other might have lost one or more residues, which is deletion. We can see in this example of two short protein sequences where after first four residues which match perfectly, we lose identity in this comparison. That means the residues are no more exactly same. And if we introduce a gap in the second sequence like this, the alignment can be more perfect. Here, this gap will represent an indel event. We may have questions like, where is the correct gap position? How does BLAST decide where to insert a gap position to maximize the alignment score? More so, with amino acid, one residue can substitute another residues with similar physical and chemical properties and therefore may score positively. So, can isoleucine or I positively substitute leucine or L? Or can valine or V substitute cysteine or C? Let's find out. BLAST-P will make use of substitution matrices like PAM or Blossom 62 to find scores of such substitutions. By default, Blossom 62 matrix is used by BLAST-P. Isoleucine, if substitutes leucine, then both are hydrophobic amino acids, and using Blossom 62 substitution matrix, this substitution gives a positive score of 2. However, if valine substitutes cysteine, the score is -1 because they both are having different physicochemical properties. In this example, the second peptide sequence is shorter by one residue. That means the gap position will be introduced here. To find the correct gap position, there can be quite a few possibilities like these. Then which one is the correct option? To find the correct gap position, we will first place a gap at every possible position like shown here. As you can see, this gap position in the second sequence is shifting by one residue from left to right, giving all possible alignments. To determine the correct alternative, we will now score each possibility by writing down their scores using Blossom 62 matrix. Also, we will use a gap penalty value of -10. So here we see all the scores. And here all scores have been put together. Now we look for the best score, which is the highest score amongst all. So we can see that 34 is the highest score. This means this possibility represents the best alignment option and the correct gap position. This is the best alignment which represents the most likely gap position in this protein-to-protein alignment. If you understood the concept, please practice this question and match your answer with my answer. Well done! Now you can perform such alignments perfectly. Hope you understood and liked this information. In my next video, I'll be teaching you about multiple sequence alignment or MSA is scoring and significance. Don't forget to watch. Thank you very much. See you.